Okay, so today we are going to talk about confidence interval. So if let me start the whiteboard. Mm, Whiteboard. Okay, so the confidence interval. So if I ask you, if you live in Spokane, you need to go to Seattle. How much time do you need to go from here, Spokane to Seattle? What's your answer? Let's say you want to travel from Spokane to Seattle. How much time do you need? Or driving time? What would be your driving time to reach from Spokane to Seattle or Seattle to Spokane? Any answer? 6 hours. Thank you, Anu. So you gave the answer. How confident you are that you will reach in 6 hours? Now, the second question.
Because I live in Quincy, so it takes me about like 3 hours to get to Seattle, and then 2 hours, 2.5 hours to get to Spokane. So I just figured it out just roughly.
Okay, thank you. Thank
Oh,
you very much. So you will live in between Spokane and Seattle.
yes,
Okay. And what is the town that you said?
Quincy, Washington.
Okay. To be honest, I don't know. Anyway,
It's like little east.
Moses Lake.
Yeah, yeah.
Okay. So another question followed by this. What would be your GPA at the end of this program MBA from Eastern? What would be your GPA?
I can't really tell,
No,
but
just yeah, just guess. I just want to hear.
okay. Probably above 3.8.
Okay, very good. So I got two answer. Once he said spoken to Seattle, and we need 6 hours. Okay, this is one. And GPA, and C said probably 3.8 to 4. I mean, this is your answer because you said above 3.8 means in this range. Which one is correct answer?
3.84.
Which one is correct answer? Can you think about? Everyone in the class, not only Anu. Is this correct or is this correct?
I think the second one.
Exactly. Yeah, this is correct. The reason is why? Because here we are giving a range. Here we are giving a range. It will be between 3.8 to 4. I mean, we have given the range. Okay. Which can be 3.8, can be 4, can be 3.9, can be in between any number. Okay. So, but you are saying 6 hours. It is not necessary. Maybe you can reach in 4 hours. You can reach in 5 hours. So usually whenever such kind of questions are asked, your answer should be in the range of some numbers. So if I ask, going Spokane to Seattle, like I drove one time in 4 hours, and sometimes worst condition traffic or something, 5 hours. So this is 4 to 5 hours. So basically, our answer should be 4 to 5 hours, like you gave exactly this, that above 3.8 means it has a range. But there's another question comes. How confident are you that you will get 3.8 to 4 GPA? For example, this, how confident you are, and there's a probability. Let's say I can say I'm 95% confident that 95% confident that my GPA will be between 3.8 to 4. I'm 99% confident that I will reach from Spokane to Seattle between 4 to 5 hours. Okay. So what is the chance here? 95%. Still you have 5% chance. So you can't go beyond, 4, but here there's still 5% chance, because many probabilistic situations may occur. You never thought, you never know about the future. You never know about the exam paper. You never know about the grading of the instructor. Many, many ifs and buts can be. Still, you are 95% confident, 5% you are having a risk that it may go below 3.8. Similarly, here, 99% that you will reach in from Spokane to Seattle in 4 to 5 hours, but still 1% chance it may take more than 5 hours, or it may take less than 4 hours, isn't it? Maybe many scenario you can think of. So basically, we are looking the confidence interval. What should be the confidence interval? And so this is a probability, or this is a confidence level, and we are going to look the numbers plus minus, because always in probability, let's say if you are asked what should be the salary, you can't give a particular number, $4,585. No, you can't give exact number. You can say, some range, 4,500 to 5,000, or some range with 90% or whatever confidence, isn't it? So this is the motto, or this is the purpose of, this is the uh, implication of this chapter. Okay. If it is clear to everyone, I will go to next thing. So let me clear this. Clear. So just a minute. Share screen. Okay, here. Can you see my screen here? And now, if you can see, okay. Okay, here we go. So this is, and another thing, you remember this. So we take the sample from population, and we would like to see whether this sample represent the population or not. Okay. What is another thing? From this chapter onwards, we are going to start inferential statistics. What is the inferential statistics? Let me explain here. So let's say this is a population. Let's say from population, we take sample, and using analytics or using statistics, we generalize about population. So based on sample, we characterize, or we generalize about population. Inference, basically it is called inferential, or we infer about population. Now, let's say this is having 23,000. 23,000 and we are taking only 500. How confident we are this 500 representing the true population? So I'm giving you one real example and then we will move ahead. So Indian student. So if you can see my mini tab, the data must be popping up. Okay. So this is the real scenario. Here, every year, like US having 300,000 international students come to USA for higher studies or from different countries. Every year, about 23,000 23,000 students come from India. And this is the data from those students. So, for getting admission in US university, one has to have GRE score or GMAT score, TOEFL score, university rating, a statement of purpose that why they want to study in this university, letter of recommendation uh, from their boss or professors. GPA in India, GPA is usually 10-point score. So it is like here we have 4-point GPA scale. In India, it's a 10-point GPA. So you can see this is research university like Eastern is a non-research university or teaching university. University of Washington, WSU, they are research university. So whether research or non-research university, chance of admission. Okay, so these are the we gather out of we gather this information from 500 Indian students coming to US, I mean, those who come to USA. And based on this sample, we would like to know. So this is 500 student sample. This is TOEFL score of 500. What is the score of all the 20,000? So basically, we 23K, we take 500 students. So based on this 500 students, I'm going to predict what about all 23K students GRE and what is the TOEFL score of all 23K based on this 500 students with some confidence level. And certainly because we can't predict, the GRE score will be 322, we can say the range of this with what confidence. So I'm just going to take one variable here. Let's say GRE is very important component when you come to the international. So I go under statistics, basic statistics, and here one sample t-test, and here and here we have 95% confidence level. That means I can say I'm 95% or 9. You can change all these things, 95, 99 or different numbers, different confidence interval. Now you can see these results and let's see, I can make it bigger. Can you see? So this is a GRE score. So based on this, what I can say, based on this 500 sample, I can say all Indian, all means all 23,000 or whatever numbers are coming, all Indian students who are coming to USA, their GRE score will be between 315.4 to 317.46, means in this range with 95% confidence. I'm 95% confident that all the Indian students are coming to USA, their GRE score will be in the range of this. Still 5% chance, 5% that it may go below this or it may go above this, but largely 95% this. Is it making sense? So based on sample, based on 500 numbers or sample, we are saying about all 500, sorry, 23,000 people. Similarly, if you do any study of Washington, you take the sample from each county and you generalize about, or you take, some counties and you predict about, or you generalize about Washington, where you are not going to count every individual or every single sample, only few of them. And practically, you can't do that, isn't it? So this is one of the simple interpretation. Everyone is clear about this? So now, higher the confidence interval, the range become longer. You say I'm 99% confidence. Let's see, this will be bigger because your confidence in increasing. Let's say I'm 99.99% confidence that I will reach to Seattle in 10 hours, 4 to 10 hours, and my confidence is 99.99%. Because I take this much, certainly I will reach. Doesn't matter if uh, we'll have some traffic jam or some problem. Maximum 10 hours is sufficient, because any traffic issue will be cleared by that. So that's why if I say 4 hours to 4.4 hours, 10 minutes, then I need to reduce because only 10 minutes difference. I will reach to spoken to Washington and I'm 80% confident. Here you increase. So when you have a smaller confidence interval, the range is smaller. When you have bigger confidence interval, the range is bigger. So let's look into the same thing. I'm just changing here 95 to 90, and then I'm going to do 90. So statistics, basic, and oh, sorry, one sample. Now here I change to first 90, then I will do for 90%. So this is 90, and then I can do for 99. Okay, so this is 99%. So what we have at 95, this is 315.480 to 317.46, which is almost 2. Now look into the 99. So we increased the confidence level, the range also increased. 315.166 and 3. So basically almost half, point 0.5 uh, range increased in this case. Now look into the second 90%. So here you have almost zero point 0.4, zero point 0.5 range is decreased. Here 3.5. Is it, are you getting it? So what are the decisive factor here? So here, if I show you, so this is very simple, and this is the formula that this is the formula. If you remember this, so mu plus minus g sigma upon square root of n. So you see 90%, 95%, and 99%. So which factors are, if you have a small standard deviation and bigger sample size, this difference is smaller. What we need to do? What we need to do? Mu plus minus g sigma upon square root of n. So average you can't touch. G value based on confidence. So 1.64 different confidence, different Z value. Now, if you, our purpose is to keep this smallest so we can have more precise value. We can have more precise range, higher confidence, lower confidence, sorry, higher confidence, but lower range. So only the data should have consistency, means smaller standard deviation means higher consistency. The sample size, if you have higher sample size, this whole will be less. So how you can get better consistency in range? When you have data consistent or very high sample size. So therefore higher sample size is always recommended. So many question in the fill in the blanks is only asking about uh, mu z sigma upon n square. So plus minus, if you hear the this situation, this is the asking. How you can do this? So basically this is a mean 3.16.472. This is a mean. And this is your one-sided. Either one you can plus or minus, doesn't matter. So I just do minus 3.15, sorry, 315.64. Sorry, 315. So if you do this calculation, whatever value you will get, that is the this value. And question is asking many, and this is called margin of error. Margin of error. Please bear my writing because using mouse. So you understand this? If this is clear, is it clear?
Yes, it is.
Okay, perfect. So only this is the thing that you need to concentrate, you need to choose different confidence. Now this is also based on three scenario here we have. Now look into one. So when I go to statistics, basic, you need to see one sample Z, one sample T, one proportion. Can you see one where proportion, one T and one Z? So one sample. Why? When do we use Z? When you have known standard deviation of population, means not sample, population. If I know the standard deviation of all 23,000 students GRE, then I can use Z test. If I don't know, I go with one sample T test, which I have done because I don't know what is the standard deviation of all 23,000. And this can be also done for proportion. Let's say I want to know what percent of all 20,000 students will go to research university. So here this is the proportion, research and non-research. So I can do statistics, basic statistics, and I can go to one proportion and I can select the research part and by default 95%, and let's do this. So one is research and other is, so here is the, so basically based on sample, 56% students will be in from sample are choosing research university, but all student, 23,000 students, their choosing research university will be 51 to 60% with 95%. I'm 95% confidence their research, most likely, or 90%, 95% confident that 51 to 60% students will go to the research university. And so this is related to proportion. This is related to, because you don't know the standard deviation. Let's say if I do the same thing, basic statistics, And let me check the GRE. And here, standard 11, 12. Okay. Basic statistics, one sample. Let's say I'm going to do GRE again. But I know through GRE scoreboard or somewhere I got to know the standard deviation of all Indian students appeared in GRE, there's 12. And then I can do the same thing and I don't need to do anything. And then this is the confidence interval. When I know the standard deviation of all 23,000 students. So these are the three scenario of confidence interval. Now there is a fourth scenario when you know the population. So basically this is the formula. So if you increase the sample size, standard, and this sigma upon square root of n is called standard error. After plus minus, this term is called margin of error. And now we go to the so basically mu minus and mu plus margin of error is so mu is a true mean of population and x bar is sample mean. X bar is sample mean. So the true mean will be in the range of plus and minus. So basically you can see this equation. So mu is a true mean of population. True mean of population will be this is lower limit and this is upper limit. This is a sample mean. This is a sample mean and this is all you can see standard deviation. So if you understand, if you increase the confidence, the range also increase. I already explained. So when we can assume normality, we can assume normality when n is greater than 30. How? You can see the value of t value and z value. They are very close when you go for degree of freedom 30. And I can show you here. Just a minute. And t value, t table, and let's say t table. And here we go. So you can see, if you can see here, I would like to. So here this is a t value. And here you can see 95%. Let's say this is 90%. Okay. So this is a z value. Z table, which is called normal distribution that just you learned in the last module. And this is t value for n equal to 1000. Now we go to 30. Look into this 30 and look into 1.645 and 1.697. So if you go 30 plus sample size, the t value and z value, they are close to edge, very close to each other. So 1.69 and 1.64. They are very close. So therefore, okay. So therefore, t distribution I already explained. Degree of freedom equal to n minus 1. And just a minute, let me remove this. Okay. So this is for t distribution. You can perform this is very simple. Now we have, so this is a proportion formula. Now we have finite population correction factor. So rule of thumb here, normality condition when n and pi equal to greater than and 1. So you remember the last binomial distribution when binomial can be considered as a normal, and the same condition is here. So this is a proportion formula, exactly the same, p plus minus. So proportion in our case, this Indian 56%, and this is rest is plus minus. Now we have a finite population correction factor, which is called capital N minus N upon capital N minus 1, where capital N is a population size and N is a small n is a sample size. So if you know that we know that 23,520 students are coming from India, that is a population, and you are taking a sample of 500, okay, then you can use this additional factor in the equation. And we don't have this option in Minitab to include this. So this is, very zero 0.9. This, usually this is coming 0.9 something. So means the entire this part is reduced. So all three formula, this is when you know sigma, population sigma. This is Z value. When you don't know, this is T value. When this is a proportion, and this is called finite population correction factor. If this is okay, we go for further part, which is called. Now, there's another question. How do we calculate the sample size? So sample size, like, for your study, what should be the sample size? So we take a margin of error. So this is called error, or this is called margin of error, Z sigma upon. So this is the formula we know, margin of error. So error equal to Z sigma upon square root. Then you just, reshuffle this equation. In order to remove square root, we do the square everywhere. And then we bring this here, and then we bring this here. So N equal to sample size equal to Z square, sigma square, E square. Z square is known because we are doing confidence interval. So 90, 95, this is from table. How we calculate the sigma and E? E is given that margin of error is 5%, 10%. In question people give, we can consider 5% error, 10% error, maybe 18%. How we can calculate the sigma? So sigma can be calculated using following assumption here. So if you remember the 6 sigma in the normal distribution, so if you look into the 6 sigma, here minus 3 sigma, here plus 3 sigma, minus 3 sigma, and plus 3 sigma. Sorry, please bear with my writing. So the range equal to 6 sigma. Okay. How we can take the range? So if you know the data, highest value minus lowest value equal to 6 sigma. So sigma equal to highest minus lowest divided by 6. If this is clear, so one is the, so this is the case. B means highest, A means lowest divided by, so you can calculate through this way, you can calculate 6 sigma. You remember Poisson equation, how we can, if you know the average, square root of average is sigma from Poisson. Uniform population, this is the situation. Take first, you take a primary or pilot sampling, and through which you can calculate the sigma and put into that data. So one thing, if you do the manual calculation, the sample size will be little different. If you do the Minitab calculation, it's a bit different. So how can I do in Minitab? So this is Minitab. I go under statistics, and here, can you see the power and sample size? Here we can say sample size for estimation. And I think this is the right one. So you can see which distribution is there. Standard deviation, you can calculate either way. Like for 12, we did for that margin of error, estimate sample, margin of error. What is the margin of error that we did in this last, which is, I think, 0.5, approximately 0.5 was margin of error in case of Indian student. And now you do what should, Oh, greater than 2. Sample size, sorry, I made. Estimate the margin of estimate sample size. So margin of error was 0.5 we have, and we can calculate. So for that Indian student, this is giving, we need to have 2,216 sample in order to conduct that study. So this is sample size, but if you put the numbers in this equation, Z, sigma, I think 12, error is zero point 0.5, and if you calculate it, there is a little difference. But I have considered both the answer, and both the answers will be correct in the fill in the blanks, because I have given you that sufficient margin of error that within that range, manual calculation and this calculation will be accepted. Similarly, for proportion, this is a proportion situation where you can do n equal to z minus e and use this formula, and you can do this. So basically, I go under this power sample size, and here you can do for proportion. Where is the proportion? Here. And you can do the proportion, you can do, and you can calculate. So this is about module number 4. Any question? If no, then I would like to say wonderful evening, productive week ahead, and we'll meet on Monday. Hello, everyone. Can you hear me? Hello? Yeah. Okay. Thank you, Rhonda. Thank you. Bye-bye. Mm.